Okay, good morning, guys. The idea of this video is checking principal features about quadratic equation. I'm going to explain um, how to identify a quadratic equation, how to find the vertex, how to identify the roots. Okay, principal issues that can be useful to understand a little more about quadratic equation. First, a quadratic equation is an expression which 4 is 8x squared plus bx plus c. It is called quadratic equation because one of the components contain an square, okay? Contain an square. That is really important. When you see an square in an expression and the square is the highest exponent, that is a quadratic equation, okay? Now, for quadratic equation, that means in this for quadratic equation, we can identify the following items, okay? Or items. The first one, the graph for a quadratic equation. The graph of a quadratic equation is a curve, okay? The graph of quadratic equation, I'm going to quadratic equation is a curve, okay? The curve, we can see the curve under a coordinate plane on this way, okay? Or on this way. That is the form of a quadratic equation in a graph. That means if you see a curve, that is a quadratic equation. Okay? Now, second, in a quadratic equation, we can identify, for example, a y-intercept, okay? We can identify x-intercepts that we call the x-intercepts also roots or zeros, okay? In a quadratic equation also we can identify something that we call vertex, okay? A vertex. And over the vertex we can identify an axis of symmetry. Okay? In this kind of curve, we can identify those principal components. Now, how to identify from the graph those components and how to calculate the components. I'm going to start with the y-intercept, okay? For the y-intercept, for example, for the y-intercept, okay? As the sentence says, is a coordinate that are crossing. For example, over here, I'm going to plot a coordinate plane. And I'm going to draw a curve, okay? For example, this curve. The point that is crossing or is touching the y-axis, that is the y-intercept, okay? And the y-intercept, for example, in a quadratic equation, in this quadratic equation, 8x squared plus bx plus c, is the component c, okay? That means the y-intercept in a quadratic equation is the component c. Writing an example, for example, we have this quadratic expression For example, if we need to identify the y-intercept in this expression, or we graph this expression, we can see that the y-intercept is equal to 10 because it's the component C of the expression, okay? That is the y-intercept. Now, the x-intercepts, okay? The x-intercepts. Now, second, we need to the x-intercepts, okay? Or as I said before, roots or zeros, okay? Again, I'm going to plot a coordinate plane. Okay. In the coordinate plane, I'm going to draw a curve. Okay. Now, the x-intercepts as the y-intercepts are points are crossing the x-axis. For example, the points I am pointing out right now, this x-axis can take two different values for x in this case, or we can find, for example, I'm going to draw two different coordinates again. We can find that in a curve we can find two different points for x, or we can find sorry for the drawing, or we can find that we only have one value for x instead of having two as the example above, or that we don't have roots. For example, if you see this curve, in this curve we don't have roots or x-intercepts. Okay? By graphing, it's easy to identify the x-intercepts. By calculating, is factorizing. When you are factorizing an algebraic expression, I'm going to do a brief example. For example, x squared plus 2x, yeah, plus 2. After factorizing this, we can find the roots, okay, when we don't have the graph. How to do it? Again, how to do the factorization? Doing the x, yeah, remember the x. The idea is multiplying the values. In this case is 1 times 2. That means 8 times c is 2. And taking the value for b below, yeah. This is b. And this 2 is the product of multiplying a times c, okay? Then, when you have this, you need to look for two numbers that after multiplying, you can get the 2. And the same number adding or subtracting, you can get 2. In this case, I'm going to try different combinations, but in this case, we don't have a combination. I made a mistake by creating the expression. Therefore, I'm going to change this number 2 by 3, okay? That means, in this sense, this one is going to be 3. Now, looking for numbers that after multiplying is 2 times 1, yeah, equal 2. And using the same numbers than multiplying, by adding, we can find that the term is 3. If we see, we get the 2 and the 3. Therefore, the numbers we can use is 2 and 1, 2 and 1, 2 and 1. We are going to write the numbers in both sides of the x, 2 and 1, okay? And as a final step in this x magic, we're going to make a bar to create a fraction, and below the numbers you are going to write the value for a, that is 1 and 1. Yeah. Finally, in the factorization, we are going to create two brackets again, and in the brackets we are going to write the denominator are the values for the x, and the numerator are the numbers we are going to include in the brackets. For example, +2 in this case and +1 in this case. Finally, if we want to rewrite this, is going to be the final answer of this is going to be x plus 2, x plus 1. But if you see, we don't have the values for x, because as I said before, in the graph we need to find the values that are corresponding to the values for x. Therefore, by taking the factorization answer, that is the two brackets, we're going to do the following step. We're going to make equal each bracket to 1. That means taking this bracket, x plus 2 equal 0, sorry, and this bracket x plus 1 equals 0. And in this case, we need to apply opposite operations. That means having this +2 to the other side is -2, and taking this +1 in this side is -1. And then we can get the roots, okay? That is the process for the x-intercepts. And finally, the third point is the vertex. The vertex, by graphing again a quadratic equation, for example, I'm going to use this one. I'm going to do two different curves, okay? And this one. Okay. The vertex is the minimum point or the maximum point in a quadratic, okay? The vertex, if you see, the vertex actually is a coordinate, okay? Is the coordinate of the minimum or maximum point. It's a coordinate xy that is corresponding to the minimum or maximum point, yeah, by graphing, okay? But if you want to calculate the vertex, you are going to use this formula. To calculate the x value for the vertex is going to be equal -b over 2a. That means if we have an expression on this way, if you see, we are going to take the value for a and the value for b to calculate the vertex in x. I'm going to do an example. And the example is going to be, for example, 2x squared plus 4x plus 8. Yeah. If we want to calculate the vertex coordinate for this expression, we're going to take the values 2 that is corresponding to a and the 4 that is corresponding to b and replace it in the formula above. The answer in this case is going to be x equal, what is the value for b is 4 over 2 times the value for a, that is 2. In this case, x equal -4 divided 2 times 2 is 4, and the value for x is going to be equal to -1. When you get the value of x, now we need to calculate the value for y, because as I said before, the vertex is a coordinate. We already have the value for x, therefore we need to get the value for y. To get the value for y, to find y of vertex, we are going to use the answer of x, okay? How? But taking the value for x is going to be, we are going to replace this value in the formula, in the expression. Which expression? this expression, okay? Now I'm going to rewrite the expression. It's going to be 2x squared plus 4x plus 8 equal y. Remember, a quadratic equation, we can make the expression equal to 0 or to y. We already have the value for x. Now, when you have an x, you can replace the value that we found before, that is minus 1. Now the formula is going to be 2 times minus 1 to the power of 2 plus 4 times minus 1 plus 8. By doing the full operation in a calculator or in your mind, you can find minus 1 to the power of 2 is 1, times 2 is 2, plus 4 times minus 1 is minus 4, plus 8. And the y value for the vertex in this expression is going to be 2 minus 4 minus 2 plus 8 is going to be 6. And the vertex coordinate is going to be minus 1, comma 6. And finally, it is the final component of a quadratic equation. Take this video as a reference of principal characteristics of quadratic equation. Have a nice day, guys.